All right, I'm not seeing it in this one. So I'll have to get some for you later on. All right, so good. So we started to look at this application already, right? And the next application we did, and this was the second one that we did. We said that dy dx is equal to something called the gradient function. So once you have dy dx, you can easily find the gradient at any point in time, right? Okay, good. Next application, rates of change. All right, next application, rates of change. Right, some people did this on Monday. I'm going to do some rates of change question and I'll keep them a little bit easier. Right, I wouldn't give any hard ones that we did on Monday. All right, nice. So how do we know? How do we know when is a rate of change type question, right? Please remember that dy dx is equal to dy du by du dx, right? There's some things to remember when applying rate of change, right? So for example, let's say I told you that the rate of change of y, right? So if you saw that word in there, the rate of change of y, right? Once you see the rate of change of y, you know that has to do with dy dt. So once you see the rate, it means that you have to include that dt there. How do we find dy dt? Well, dy dt is equal to, if you use chain rule, that's this rule right here. If you use chain rule, dy dt is dy dt and any other variable within the two spaces there. So here will be dx, dx. Okay? I think you have to pull the go ahead. You want to leave her wide open already? Okay, nice. So dy dt is equal to dy dx multiplied by dx dt. Right? So once you see the word rate, you know you're using this rate of change formula here. Right? A popular one here is rate of change of volume. Rate of change of volume will be dv dt. dv dt. Right? Rate of change of volume is dv dt and is written dv dt is equal to, same thing. We are applying chain rule. Here is dv, here is dt, and the two spaces belong to whatever variable we're using again, probably r, right? So that'll be dr, dr. All right. So we're going to apply that now in some questions, right? All right, we're going to do some rates of change. Right, that'll be the last application until kinematics. Actually, we'll do some kinematics, but I'll only give you the differentiation part of it. Right? Displacement to velocity to acceleration. Right, for next week, don't forget to look at the integration video. Right? So you can integrate before we start, right? Okay, so let's start with the example, right? So let's start here. Right, number one, the radius. Right, the radius of a circle increases at a rate of 5 centimeters per second. Find the rate find the rate of increase of the area Find the rate of increase of the area when the radius of the circle is 4 centimeters. All right. So we're going to attempt to do this one here, right? Copy down quick and we'll do this one together. Max, yeah. No, but I do it back a short away or something? Yeah. Okay, I'll do it. Take a little read and then we'll do this one together, right? All right, so watch here. So let's see what they give us, right? They said the radius is increasing at a rate of 5. So that means that we have dr dt is equal to 5. Okay, next, what else they have? They want us to find the rate of increase of area. So they want us to find dA dt. And of course, we need to write the formula using chain rule. Here is dA, here is dt, and then here is the next variable. What else they give us? They said when the radius is 4. So when r is 4. So at some point in time, we need to use r is 4, right? So if you look here, we already have dr dt. We already have dr dt. We have it here. We need to get dA dr. So to get dA dr, we need, right? We need an equation of A in terms of r. Right? Well, what equation that will be? A is equal to, it's a circle, so A is equal to pi r squared. That's okay? So therefore, dA dr, right? dA dr will be equal to, right? Differentiated, bring down the power, you'll get 2 pi and minus 1 from 2 and you'll get 1. So dA dr is 2 pi r. Now we'll be able to use when r is 4. So we substitute when r is equal to 4 and we're good to go. dA dr is equal to 2 pi by 4, right? That'll be 8 pi, right? Since it's dA dr, you'll see centimeters per centimeter squared, right? Per centimeter, which is centimeter. So therefore, dA dt is equal to 8 pi multiplied by 5. Right? Because we know dA dr and we already know dr dt from earlier. Okay? So that will be 8 pi by 5, which is 40 pi centimeters squared per second. Are you okay with that? Right? So supposed to be a simple one here, right? Notice when they use the word increase, it means that this overall value should be a positive. If they use the word decrease, then the overall value should be negative. Right? So you could put a little sign to remind you, right? So as you read the question, pick out the important things, right? So let me just show you here one more time. They give you the radius, it's increasing at a rate. So you know what dr dt is. They ask for the rate of increase of area, so they're asking you to find for dA dt. Use chain rule and get the formula. You already have this, it's just wait to get this dr. Right? So to get dA dr, we need an equation. Right? So either you make up the equation or the equation somewhere there. All right. Let's take a look at let's do our next one, right? Right, number 2, a spherical pole number 2 is spherical ball of ice is melting uniformly at a constant rate of 2 pi centimeters cube per second, right? Right? At what rate is the radius decreasing when its radius is 3 centimeters? Right? Copy it down. All right, we'll do one more together again. Right, I'm just giving you the volume of a sphere. Volume of a sphere is 40 pi r cubed. Copy down and let's do it together. If you want to do it, go ahead. All right, so let's see what we have here. So they said that a spherical ball is melting uniformly at a rate. Right, we have a slight problem here. They didn't specify what that is. Anybody can figure out what is 2 pi centimeter cube per second? Look at the SI unit, centimeter cube per second. That's volume per second, right? So they gave us dV dt. dV dt is 2 pi, right? And we knew it because we can look at the SI units and figure it out, right? At what rate is the radius increasing? Right? So what are they asking for? Dr dt. They want the radius in decreasing, so put a negative sign, right? Change it up here. You have dr here, you have dt here, and the next variable is v. So we need to get dVdr. drdv, sorry. Okay, when r is 3. Right, how we getting drdv? How we getting drdv? Anybody? How are we going to get drdv? Any ideas? Anybody online? Any ideas? How are we going to get drdv? Look at what we have here. One over, yes. Very good, Rian. Right, so we could find dVdr and then flip it over. Right, so we could find dVdr and flip it over. Okay. All right, so V is equal to 4/3 pi r cubed. So therefore, dVdr is equal to 3 by 4/3 by pi r minus 1 from the power, and you'll get 2. So you're going to get 4 pi r squared. Right, that's dVdr, 4 pi r squared. When r is equal to what? 3. When r is equal to 3, dVdr is equal to 4 pi by 3 squared. That's 9 by 4, so that's what? 36. 36 pi. So last part, dr dt is equal to -1 over 36 pi multiplied by 2 pi. 2 will cancel, so you'll get -1 on 18. Right, -1 on 18. Okay, copy down. Let's try a few. You have to pass people this, right? Yeah, pass. 1 over, because we needed dr dv. When you differentiate, we got dVdr, so you have to flip it over. 1 over means that you flip it over. Yeah? No, take it flip for 1. You'll see now, right? Right, next one. Try this here. That's a good size one. But let me see everything. You can still, probably still can't see that. Right, so that's the way you come up with there. They give you an equation for area, surface area, and they told you the radius and what they want. What they want, Shane? They want the rate of change of area. So they want dA dt, right? They want dA dt, and they gave you what? They gave you dr dt. Okay? So you have to find the dr and work it out. Right, so the last line there, yeah. Oh, shucks, I went to chat. Right, fast. Pause. Go here, hold. Right, so what they gave us here, they gave us an equation for A, correct? That's A, right? What they asking us to find? They asking us to find the area, rate of change of area. So they want us to find dA dt, which obviously means that here is dA, here is dt, and since the next variable is r, here will be dr. Right? They gave us here this value here. That's the dr dt. So all we need to figure out, we have this. Just need to figure out this here. How do we get dA dr? Paul, pick another get Pauls. Any ideas? How to get dA dr? Pauls? Sarah? How to get dA dr? Elena, help her. How we getting dA dr? Ishana? Right, so you have to differentiate this. All you have to do is just differentiate. A is equal to 4 pi r squared. So when I differentiate that, you'll end up with 8 pi r. And how do you get the actual value? Substitute r is 3. So that'll be 3 by 8 is what? 24? 24 pi. So it means that dA dr, finish it fast. Finish it quickly. And it's the same thing over and over earlier. Once you identify what you have, you're just looking for the equation, differentiate it, plug in the value. Right, so you end up with what? You end up with 24 pi multiplied by dr dt, which is 1.5. How much is that? Pi. So that's 36 pi. And give them the SI unit too, right? Centimeters squared second. 36 pi, Jimmy. 36 pi. Copy down. Let's go again. Sarah, your followers went on here. Sarah, who confused and came early? Are you okay with us? Elena, you still confused? Right? So it's the same steps, right? Let me just go it over one more time, right? And I'm going to say the same thing again, right? So whenever you're doing these questions, you're basically looking for the term rate, right? Once you see rate of change, it means T underneath. If you see find rate of change of area, well, you put that quantity on top. So that'll be dA dt. That's okay? How do you find dA dt? You're using chain rule. You put your dA here, you put your dt here. And whatever the next variable is, goes in the space here and the space here. Okay? So underneath here, they gave us the quantity R. So that'll be dr here, dr here. If you read the last line says that the radius increases at a rate of 1.5. That tells you that dr dt is equal to 1.5. So we already know dr dt. The problem is dA dr. The only way to get dA dr, you have to differentiate A with respect to R. That's what dA dr means. Okay? Right? This here means differentiate A with respect to R. So you have to look for an equation A that's in terms of R. And in this case, they give you 4 pi R squared. So now you have to differentiate A with respect to R. When you differentiate, you'll get 8 pi R. And then there's always give you what R is, or a way to find R. Okay? When you get this answer, you put that answer there and multiply it by 1.5. Same pattern over and over. Sometimes they give you an equation, sometimes you have to figure it out. All right, so let's go again. All right, see if we can reach a little further with this one. All right, then we'll try a little past paper. Try this one here. Oh yeah, 2 minutes. Try this one. What's up? Yes. Yeah. Oh, yeah. Message answers. You can leave it in terms of car if you want, right? I let's see what you came up with. Hello, working still? Oh yeah, 2 minutes again. Let's see what you got. All right, so let's see what you have. The question said the volume is this. So they gave you V is equal to 4/3 pi r cube, right? The total radius is increasing at a rate, so they gave you the r dt. The r dt is equal to 0.3, right? And then they wanted to find the rate of increase of volume. So they wanted to find dv dt, right? They wanted to find this when r is equal to 3.5, right? So that's all the information you have there. So first thing first, let's find dv dt. Here is dv, here is dt, right? The next variable will be r, right? We already have dr dt, that's this value right here. So we need to get dv dr. V is equal to 4/3 pi r cube. So to get dv dr, we're going to differentiate. Bring down the power, go back before pi and minus 1 from the power. So we will end up with 4 pi r squared. That's our dv dr. Right? So since we have dv dr, we just need to get the actual value. So when r is what? When r is 3.5, dv dr is equal to 4 pi by 3.5 squared, right? I'll leave it at that for now, right? 49 pi. So dv dt is equal to dv dr, which is how much? 49 pi multiplied by, which is 147 over 10 pi centimeters cubed per second. What's the value? What's the actual value? Some people send the actual value. 46.18. All right, good job, Jamie, Amanda, Michael, Tabisha. Nice, Michael, good. Kachali, got it? All right, next one. Right, so I'm going to give you an idea what the full question is, right? A rates of change, differentiation, or thing, right? I can't do kinematics because plenty of the questions in the past papers you have to integrate. Yeah. Time for the real thing. Time for the real thing. Right? This is 20 something, right? 2012 or 15. There's the full question, right? Try that, please. Try everything. Differentiate the product. You use the right rule, use the stationary things, and use the last part. So I want you to do everything here. Pause, do everything here. You'll see in there. Go ahead, do that, please. Right, do the entire thing there. I should take you around 15 minutes, right, or less. Try the whole thing. What's the rule you're using for the first one? Product rule, right? Product rule. And then you're applying the stationary and so on, right? If you want to try this, the last part first, is up to you. Since that's fresh in your head, right? You can try the last part first if you want. Right, make sure you finish up the last one, right? I do the last one first. All right, no, I'll start from the top. I'll start from the top. Right, you should be done with the first one already, so I just don't correct it there. Right, I started with the last one, right? This is your U, so you're using product rule, right? 2x squared plus 3, and V is equal to sine 5x. So du dx is 4x, dv dx is 5 cos 5x. And then you use your dy dx, right? You multiply it out, so that'll be u by dv dx plus v, which is 4x by sine 5x. That's it. You're done. 4 marks there. You can't simplify anymore. Wait, could you? All you could probably do is just multiply it out, but there's nothing you can really do there. Huh? And this. Now, if you expand, there's nothing to do. There's nothing to expand it into. Right, part 1. Go ahead. Do the stationary points first and the last thing. Hurry up. Finish? I giving you a few minutes again and we can correct all that, right? So that's it for applications of differentiation except for kinematics, right? When we complete integration, I'll do some kinematics. I actually think I have an old video on kinematics, so if you look at. Finish already? Finish the last one, the rates are changed for sure. All right, so let's start it, right? First thing first, let us deal with y is equal to x cubed minus 5x squared plus 3x plus 1. Okay, let's deal with this first, right? So they want us to get the stationary values, so we need to get dy dx. That'll be 3x squared minus 10x plus 3. We let dy dx equal to 0, and we'll get 3x squared minus 10x plus 3 is 0. X is what? 3 and a third, right? And what was the corresponding y value? Minus 8 and 40 and 27. You need the y value because they are actually points, right? That's okay? Can I get up for the y values? Supposed to find the y values as well, right? Because they ask for all the stationary points, so you need the y value as well. And then last part, nature. How you find nature again? Right, find the second differential, d2y dx squared. So that'll be 6x minus 10. So you plug in x is 3 and you will get it more than 0, therefore it minimum. Then you plug in x is equal to 1/3, you shall get it less than 0, therefore it maximum. That's okay? That's it? You done? Easy marks. Can I get easier marks on that? What's that? That's 5 easy marks now. 9 easy marks so far for a little differentiation, provided you learn it. Right, did you all finish the rates of change? Look, Amanda finished and type out all the answers. Chevelle, did you get through the rates of change? Trouble? You can reach here yet? Yeah. That one. Elena, you remember to differentiate? We'll have to test on that next week, yeah? Okay. You plug in the x value. I know you want to ask that, not just waiting. Plug it in the equation with y. Right? You can't plug it back into this equation because you'll get 0. Yeah, no, I know you want to ask that, just waiting. Right? So you have to plug in the x value back into the y, right? Because they ask for the point. So you need all of that. All right? Yeah? Last part, the rates are changed. Right. So for the rates of change, they gave us the volume, right? So they were really nice to us. They gave us the volume. Well, one of the years they didn't give you this formula, so you had to learn these small things, right? They gave you the rate which the volume is, I mean, the balloon is being filled. So dV dt is equal to 200 centimeter cube per second. All right. So they gave us dV dt, and they would like us to find dr dt. Okay, when R is 10. So when R is 10, they want us to get dr dt. So therefore, we do the usual thing. Here is dr, here is dt. You put your V here. Right? We already have dV dt. We just have to get dr dv. Just like the one we did before, dr dv is equal to 1 over dv dr. So we just need to get dV dr. Right? dV dr is what? 4 pi r squared, right? Identical to the last one, we just have a different value. So you should have no complaints for this one, right? 10 squared, that's 100, so that's 400 pi. So the final answer will be 1 over 400 pi multiplied by 200, which is 1 over 2 pi centimeters per second. That's it. They said to leave the answer in terms of pi. And that's it. Only you're not going to get easier question on this differentiation. Make sure you can differentiate. Right? Are you okay with this? Right, next day, I would like you to look over the integration video. So I'll review quickly how to integrate, and then we do the applications. Right? And the last day is kinematics. Now we have one more day after that. Right? Right? I'm going to just give you an idea what your crash course will look like. I'm going to share this in all the groups tomorrow. Right? Not today. I just want to add in Spanish. Just take a look here at what the crash course looks like. That was 2015. Oh, take a booklet. Huh? You know, you like to forget a booklet and then blame me. Sir, you lost. I'll leave you thing down there. Right, so watch this here, right? This is what the timetable will look like for the crash course. I will send you the registration form and all those little things. All you have first preference, right? You have until around the 15th to pay off it, or the 20th, somewhere around there. So if you look here, this is the timetable, right? Some people, like the teacher from NAPS, she's doing 2 days for chemistry, right? I don't really like that. I like to do more days with math subjects, right? So she's doing 2 full days, 8 to 2 o'clock. I'll fix the timing, right? Math starts on Good Friday. So if you know you have a holiday, you can take the first day online, right? If you want. All right. And physics is right after. I'm going to share this, so don't worry, you don't have to write. Math starts on the 12th. There's not much time, you know. Math's going from the 12th straight down to the last day. Okay. Right, we have IT, POB, geography. We have all the major CSEC subjects, right? English E, yes, she chose the Wednesday before. Right? So that is your timetable there. Right, so I'll share this on the group. Right, I'll share the registration form as well. Okay. Right, so you just print your form, you're writing your subjects and your book your space. It used to be by seat number. I don't know if I'll keep that, right? So now normally when you book your seat, you have that seat number is yours. But I will see. I'm not sure if I'll keep it like that this year. Or just book the space and who comes first, take your seat. Right? And the door should be open. I mean the gate should be open about 7 o'clock. Yeah, our security guard will be. They will meet me. All right, so that's it all here. Add mass people, you all can log out. Mass people, hold on for 5 minutes, right?